Okay, welcome. So we are going to work on this example here, which, reading it, a constant horizontal force of 27 newtons pushes a 20 kilogram mass through a medium that resists its motion with 0.3 newtons for every meters per second of speed. The initial velocity of the mass is 9 meters per second in the direction opposite to the direction of the applied force. We want to find the velocity of the mass after 30 seconds. Okay, so I heard force in this equation or this problem, so when I hear that, I think of mass times acceleration equals the force. And acceleration, you remember, or you might remember, is just the second derivative of a function. And so, doing that, we know we are looking at a 20 kilogram mass, so that should be for this m, so 20, and the force here we can read in here because we're looking at 27 newtons being pushed one way, one direction, and then there's a resisting kind of force happening for every meter per second. So that right there, I mean, already you can kind of hear velocity, and it also says find the velocity at that mass. So what we can do, because I think we need to have some kind of velocity variable in there, we know that the second derivative of a function, like it's y of whatever, is just the derivative of velocity, right? Similarly, we know that y prime is just going to be velocity, right? Kind of going backwards there. So that being said, now we have essentially a variable that represents velocity. We can actually plug in stuff like the second derivative y double prime is just velocity prime, and then the force, we can continue what we were analyzing here. So 27 newtons, a force of 27 newtons, and then there's a medium that is resisting that motion with, so that's going to be minus 0.3 newtons for every meters per second, which again is in velocity. So, whoops. So there we go. So that's nice because now we have a nice first order differential equation that I believe we can solve. We also are given an initial condition of the initial velocity being 9 meters per second in the opposite direction. So that's going to be negative 9. Right? So that might help us too. And we could solve this. Right? So what I am going to do is divide everything by 20 and actually move things around a little bit. So I'm going to move the v stuff on the left side and divide by 20, giving me v prime plus, and I'm going to write the 0.3 as a fraction, 3 over 10, and then actually, because it's divided by 20, it's going to end up being 3 over 200, and then v being equal to 27, right? Whoa, I almost forgot the over 20, because I divided everything by 20. And then we have You get a first order linear differential equation that we can solve using integrating factors. It's already in that form. I'm going to write the work for the integrating factor over here. That's just the taking e to the integral of the number in front of the v variable, which is going to be just 3 over 200. And integrating that, I forgot to write the dt. And integrating that, we get e to the 3 over 200 times t. And that is our integrating factor. Multiplying that integrating factor to the whole differential equation, we'll get 3t over 200 times v prime plus 3 over 200 e to the 3t over 200 times v, being equal to 27 over 20 times e to the 3t over 200. And what's nice about that is now I can rewrite this as the derivative of the product of the integrating factor, which is e to the 3t over 200 times v, being equal to 27 over 20 e to the 3t over 200. And I'm also going to write the dt on this side because we are going to integrate both sides. But I always like to point out the step of the reason why we like the integrating factors, because once you get it, you can write the integrating factor times the product of the, in this case, v variable. It equals that above step right there. And also makes our integration nice because the integral of a derivative cancels itself out and you're just left with e to the 3t over 200 times v, being equal to 27 over 20. And I'm going to put the e to the 3t over 200 because the integral of e to the 3t over 200 is itself, but we do have to write the fraction part in front, which is going to be 200 over 3. The reason being, when you take the derivative of e to the 3t over 200, you get e to the 3t over 200 times the derivative of this, which is 3 over 200, and you need them to cancel out to actually equal this part. So there we have it. We can simplify this a little bit. This is 3 goes into 27 9 times, 20 goes into 200 10 times, and we are left with e to the 3t over 200 times v, being equal to 90 e to the 3t. And I did almost forget a step. I just didn't want to write it up here yet. But we do have that constant after we integrate, right? So that's nice. Also, because we want v by itself, and I'm going to actually write it as v of t, we'll divide out the e to the 3 over 200 on both sides, and we end up with 90 plus c times e to the negative 2t, or 3t. Let me just erase that and try to write that nicer. E to the negative 3t over 200. And I mean, that's essentially part of our solution. We want to find the c. We are given the initial condition of -9 when t is 0, so we can plug that in, which gives us negative 9 being equal to 90 plus c times e to the 0, which is just 1. And then that actually just gives us c being equal to negative 99. So our velocity is going to equal 90 minus 99 e to the negative 3t over 200. And what's awesome about that is that's almost what we need. If you remember, we are actually trying to find the velocity of the mass after 30 seconds. We started out with y double prime because we thought of mass times acceleration, and then we realized it was written in terms of velocity, so we adjusted that a little bit with this, and we solved our differential equation, and we got this wonderful velocity equation. And now we can answer this question of finding the velocity of the mass after 30 seconds, which is just going to be 90 minus 99 e to the negative 3 times 30 over 200, and then we can just plug that into our calculator because I don't want to evaluate that by hand. And that is about 26.8748 meters per second. So while unboxing this, we now know after 30 seconds the the velocity of the mass is about 26.9 meters per second. I hope this made sense.